All right, guys, we're on day 2 notes. We're going to talk about graphs of logarithms. So we saw what a graph of a logarithm looks like. We know what exponential growth or decay looks like. In the inverse of an exponential is a logarithmic curve. So you already know that it's going to look like a reflection over that line y equals x. So in number 1, it says that the function f of x equals 2 to the x is shown on the graph. And we have to know that this is an exponential. And if you look at the graph or you look at that your base is more than 1, that this is exponential growth. All right, and so looking at the picture, it makes sense. And they want to know what is the name of this function. And we're going to go ahead and say exponential growth. Okay. Next bullet says, what is the domain and the range of this function? And so we'll go ahead and say domain, remember, is left to right. And this left arrow right here is going towards negative infinity. And even though that this right arrow is going up, it is still going towards the right. And so that's positive infinity. And so we could say our domain is all reals. Or we can say negative infinity to infinity. Okay? Our range, remember, is low to high. And even though this looks like it's still going down, and it is, but it's not going to go down past the x-axis because that's the asymptote of it. And we're going to go ahead and say that the lowest it goes is 0, but we know that it's not actually going to reach 0. It's going to get close to 0. And so when we write our range, we're going to put 0, but it's not including it. So we put a round parenthesis, comma, and we look at to the top of it, and it is still going up. And so we say that it's heading towards positive infinity. And there's our range. Okay. Now they want to know what is the equation of any asymptotes, which we just talked about, is the x-axis. However, that's not an equation. So we have to remember that the x-axis is a horizontal line. So think y. Think y equals the number, which is 0. Y equals 0 is the equation of your asymptote, which is this nice horizontal line that traces right over your x-axis. Okay. Next bullet says describe the end behavior as x approaches infinity. So we'll go ahead and say it as x approaches infinity. So as x goes to infinity, which is this side, so we're going to look at this arrow. Okay, what is the y's doing? They're going up. They're heading towards positive infinity. So as x approaches infinity, we could say f of x or we could say y. It does not matter. F of x is approaching infinity as well. Okay, so as x gets bigger, y is getting bigger. Is basically what that means. All right, then we have another one. So now they want to know as x approaches negative infinity. As x approaches negative infinity, so we're looking at this end here, we can go ahead and say that f of x, what are your y values approaching? Well, they're approaching 0. They're getting closer and closer and closer and closer to 0. Okay, remember that they won't cross over the asymptote and head towards the negatives. So your y values can only get closer to 0. Okay, they can't get closer to the negatives or the negative infinity. Okay, all right. Next up, we have write an equation for the inverse and then graph the inverse on the same axes. All right, so we're going to go ahead and write the inverse. Remember the steps in an inverse, we just reviewed them in the warm-up. And so the first step is to switch x and y. And so remember our original equation was f of x equals 2 to the x. Remember that f of x is really y, so we'll put a big fat y over it. And now we're going to go ahead and switch x and y. So this big fat y is going to become an x equals 2 to the y. All right, now they're switched. Remember the second step is to solve for y, but when y is an exponent, we know we need logs. Okay, and so we're going to go ahead and write the word log. All right, and now here's where we have to remember, okay? When it's an exponential form and what it looks like in log form. Okay, that's our little cheat sheet off to the side. So now that we wrote the word log, we know we're looking for a base. And remember in exponential, the base is what the exponent is living on, which is our 2. So our 2 becomes the subscript. Okay, next is the n, which is on the normal line of writing in exponential form. It's what it's equal to, which in this case is x. And then equals our exponent, which should be easy to find. It's up in the air, which is y. And now by putting it in log form, it's in y equals form, and our 2 steps of our inverse are done. We switched x and y, we solve for y. Okay? And now they want us to graph that. All right, so I'm going to think about where I have some room. Maybe I'll do some over here. All right. So we can get the points on our inverse graph 2 ways. We can type this equation into y equals, or we can take all the points on the graph and switch the x and the y on them. It's completely up to you, but since we're graphing, instead of pulling the points off and then switching them, getting the new points and then graphing them, let's put it in our calculator, but I have to show you guys how to put it in your calculator. We talked about this a little bit on day 1, but our equation is y equals log base 2 of x. If we want to put this in our calculator, since we don't have a subscript button to type that in, we're going to do what they call change of base. So that's log divided by log. The x goes on the top and the 2 goes on the bottom. 2 is the base, it goes in the basement, which is the denominator. And now we can go to y equals, and we could type that in. Log x, close the parenthesis, divided by log 2, close the parenthesis. And we'll go to our table. And in our table, you're going to notice that at 0, there's an error. Okay, at 1 is 0, 2 is 1, 3 is a little bit of an ugly decimal of 1.585, 4 goes with 2, and 8, we'll skip 2, goes to 3. All right, this should be enough points to give us our graph a nice shape to it. Okay, so we'll go back up a little bit and we'll go ahead and graph those points. So 0 has an error. Well, we can't graph that. All right, but what that means is that there won't be any points on our y-axis. Okay, 1, 0, we can graph that. 2, 1, 3, and 1.5. So maybe like right here. 4 goes with 2, and 8 goes with 3. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. All right. If you look at your graph, so if you go to the picture in your calculator, you're going to realize that it's getting closer and closer to your y-axis. And then it looks like this. All right, and so this is f inverse of x. Or we could have put our equation there. All right, and you'll notice that that looks like a reflection over this diagonal line called y equals x, which is what an inverse is. It's a reflection over this line. Okay, so you can see if you fold your paper along that yellow line, you would have your exponential growth fall right on your log curve, which is its inverse. Okay, now we have to answer some questions about our inverse. Okay, so here we go. Now they want to know what the domain is. All right, so left to right. Well, it doesn't keep going to the left. It keeps going to the left to a certain point. So we have to realize that our y-axis is now our asymptote. And so we're going to go ahead and put 0. However, it's not going to touch the y-axis because there's an error there. And so we're not going to include 0. Therefore, we give it the round parenthesis versus including it, giving it a square parenthesis. If we go to the right of our graph, it's going to the right. And so it's heading towards positive infinity. Okay. And if you want to do a quick double check, remember that in an inverse, x and y switch, therefore domain and range switch. And so the domain of our new graph should have been the range of our old graph, and it is. Okay. And we can do the same thing with our range, or we can look at our picture. It is still going towards down, which is negative infinity. And as it goes towards the right, it is still going up slightly to positive infinity. Or we could have said all reals. And if you want to do a real quick check, that should have been the domain of the original, becomes the range of the inverse. Okay? Our y-intercept, none. It's not going to touch the y-axis. Okay? Your x-intercept, there is 1 though. Where it intersects the x-axis is at 1. Okay? Or you could write the coordinates 1, 0. Okay? But if you're talking about an x-intercept, it's taken that the y is 0. So we don't have to write it. Our asymptote now is the y-axis. However, that's not an equation, so we have to remember that the y-axis is a vertical line. So think VOOX, think x equals a number, and it's going to be x equals 0. Okay? They want to know the end behavior. So as x approaches infinity, we would tell them that y approaches. So let's go back up to our graph and see. As x approaches infinity, what are your y values doing? As x approaches infinity, which is this side on the right, okay, your arrow is going still slightly up, and therefore up would be infinity. Okay. As x approaches 0, what is y approaching? Okay, so if we go back up and we take a look, as x gets closer and closer and closer to 0, your y values are going down, 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 down. And so we'll say negative infinity. Oops. All right. Features needed before graphing logs. So you should always be acknowledge, I guess I should say, where your asymptote is. So you don't plot any points on that line or cross over that line, okay? Usually people will graph it with a highlighted line or a dash line, or some people will do a highlighted dash line, doesn't matter, okay? Your x-intercept should be included. There should be one, okay? And if there's a y-intercept. And the only time we're going to get a y-intercept with our logs is if there's a shift or something that makes it translate on our graph, because normally there wouldn't be a y-intercept. All right. And we have one last bullet over here before we flip the page, and it says what transformation maps f of x, which is our original, onto our inverse. And we know that that's a reflection over the line y equals x, which we already talked about up there on our graph. All right, I'll see you guys on the second page of notes.